This presentation explains probabilities, which form the basis for predictive modeling. Other presentations have covered the SQL for predictive models. Probability is a quantitative measure of uncertainty, ranging from 0, where the event will never occur, to 1, where the event is certain to occur. Conditional probability shrinks the universe of possibilities. For event B to occur given A, the universe is reduced to the circle A instead of the rectangle, the white rectangle, which is the total universe of possibilities for all events if there are no conditionalities. Two basic rules of probability are the multiplicative rule and the addition rule. However, the outcome depends on whether the events are independent or conditional, where the occurrence of one event affects the other event. This slide shows the additive rule of probability, where either an event or the one event or the other occurs. If the two events are independent, then the probability of both of them occurring, probability of A and B occurring, is 0. So that the outcome is just the probability of A plus the probability of B. Probabilities can be applied in healthcare, where we consider the possibility of enrolling a frail elderly and an infant in an insurance plan. Since probability of being frail and elderly or being an infant is independent of each other, the probability of being frail and infant is 0, so that the probability of enrolling a frail elderly or infant in the plan will be the probability of frail elderly plus the probability of infant. Probabilities are related to odd ratios in such a way that the odds of an event is the probability of the event divided by 1 minus the probability of the event. The base formula is a model for revising our existing opinion given new evidence. The new evidence here is the likelihood ratio that you calculate from the data, or you calculate for a particular event. So that given the prior odds, the posterior odds can be calculated as the likelihood ratio times the prior odds, where likelihood ratio refers to knowledge of the clues. An application of this in healthcare is the prediction of posterior odd of hospitalization of a frail elderly female patient, given that the age and gender are conditionally independent. If the likelihood ratio associated with frail elderly is 5/2, thus its odds ratio is 2.5, and being a female reduces the odds of hospitalization by 9/10, whilst at the same time our prior odds for hospitalization is 1/2, then the posterior odds of hospitalization is 5/2 times 9/4 times 1/2, which is 1.125. Contingency tables offer an easier way of calculating probabilities. In the table as shown, the total sample size is A plus B plus C plus D. And for instance, the probability of variable 1 occurring is A plus B divided by the total sample size. The probability of the event not occurring is C plus D divided by the total sample size. From the contingency table, the odds of variable 1 occurring is A plus B divided by C plus D. Since we know that the odds of an event is the probability of the event divided by 1 minus the probability of the event. And in the formula above, A, the denominator in the upper part, A plus B plus C plus D, is divided by the denominator of the lower part of the fraction, which is also A plus B plus C plus D.